All right, hey class, what's poppin'? So okay, what I'm gonna do is I'm gonna start with something you already know. Look at this guy right here. This one. Yeah, you know that. That's slope. So we call that gradient, or now you know this is the average rate of change. So we're gonna find out this line here. Cool. All right. Need 2 points. 1 point here, 1 point here. Look at that. Made it so easy that the intercepts, x and y intercepts. So this one will be, let's see, 0, -1. I think I did that right. I graduated high school. This is 2, 0, because the intercept. Okay, cool. Okay. Now we're just going to put it in this little equation right here. It's the slope function, or gradient, or average rate of change. Watch this. So this is going to equal, wait a second. So I think we are a little bit older now, so we can understand a little bit better mathematics, in terms of notation. So I don't really like that y2, y1 thing. So I want to define it in a way that's more, heavy level IV. So you know that y equals f of x. This is the same thing. It just means that to get y, you plug in x to the function. Well, we're going to apply that here too. If I want y2, I am plugging in x2 into the function. If I want y1, I'm plugging x1 into the function. x1, I can do it, x1, like that. Okay, so now I can just rewrite this like, x2 minus x1. And up here I'll have f of x2 minus f of x1. It's just, that's the same thing as saying y2 minus y1. Okay, cool. So where am I getting my numbers from? Up there on the graph, right there. What are you doing? Okay, look. Okay. This is x1, x2. So now I can say this is f of x1. This is f of x2. It's just the same thing as y1 and y2. So I'll just do, 0 minus 2. Nope, minus -1. Made you look. All right, and then 2 minus 0. 2 minus 0. So I get my slope, or average rate of change, is going to be, double negative. Oh, yeah. It's going to be a positive 1 over 2 minus 0 is 0, 2. There we go. So this is our slope, gradient, or average rate of change here. Yay. Okay, so let's go ahead and apply that to this right here. So we're going to find the slope of a curve. So if you notice, a curve isn't constant like a line. Slope is always changing depending on where you are on the line. So like right here, the slope here is not the same as the slope up here. And if you see what I'm drawing here, these little lines, it's called tangent lines. Tangent. That means it touches the curve at 1 point. 1 point. Okay, so what I want to try to do is, we're going to use what we did a couple classes ago with the average rate of change. So if I can't find the exact slope here, I can find the average rate of change by using 2 points on the curve, like this one here and this one here. So, okay, let's just say, I don't know my exact numbers, but I know this is going to be x, and big boys and big girls, f of x. That represents y. We plug in our x and we get our y value, function at x. So now this one, how would we describe this one using what we just learned? Well, this one would be, x2. And you probably think, this is f of x2. If that's what you said, good. Gotta college this up a little bit. Now college it up a little bit. All right. So you understand that this here, that'll be my x value. This is x-axis x. So this is x. And then we're going to get, we're going to be here, this x value. Now, what this really is a change in x. So we're adding some number, some amount, we don't know, let's just say h, to x. So this is going to be x plus h. So this is our x1, now this is our x2. It's just our x1 plus some value of h, because we just changed it by h. So this is going to be x plus h. So now if I want my y value, remember I just take this, put that in the function, so it'll be f of x plus h. So then now this will be my x2, y2, like that. Probably already know where I'm going with this. We're going to put this into that slope function. And here it is right here. So let's try it out. So that's y2, y1. So I'll say this is f of x plus h minus f of x, y2 minus y1, over it's x2 minus x1. We have x plus h minus x. Oh, and look at that. X minus x. So we're left with f of x plus h minus f of x over h. This is the basis of our derivative. this right here. This will help us get this slope or this tangent line right there at that point. And what I mean by that is we're going to start messing around with this value right here, h. We're going to start making h smaller and smaller and smaller until we get infinitesimally close to x. And what I mean by that is if we keep changing this h here, eventually we're adding a smaller number. So it'll be x plus a smaller h, x plus another smaller h, and we keep getting closer and closer and closer. And the reason why we want that is if I'm drawing my lines, my average rate of change, I'm going from here to here first, and then here to here. And then as you see, as I get closer and closer, I will eventually get that tangent line that I want. And I'll show you how that's done. Okay. So here's a little example of what I'm talking about. And here's our derivative function right here. And I'm going to put this in front of it. Limit as h approaches 0. And I'm saying that because, remember, I'm trying to make the gap between here and here as close to 0 as possible so that I can get this tangent line at that point. So in this example, let's just say our h is 0.5. So then this will be x plus 0.5. So then my point here will be the x value is x plus 0.5, because as you see, we just added 0.5 to our x1, which means that our y1 would be x, or f of x plus 0.5. So then if I want to apply this here, remember, that's our function. We're getting closer to 0. We're starting at 0.5. So we have f of x plus 0.5 minus f of x over, and then I'll have x plus 0.5 minus x. And so I'll end up with this canceling out. So I have f of x plus 0.5 minus f of x all over 0.5. That's my h. And I'm just going to continue this because, again, I want to get closer and closer and closer. Maybe here, then here. Because if I get really, really close there, you see that I will almost exactly have that tangent line. Boop, like that. All right, so let's give it another try now. You see here, h has gotten smaller. Let's say h is now 0.25. Getting closer and closer and closer. So I'll say this is x plus 0.25. So I have x plus 0.25. And then f of x plus 0.25. Remember, you're plugging in this into your function to get the y. So again, this is still x2, y2. So now I'll just apply this again, y2. All right, so I'll do f of x plus 0.25 minus f of x over my x2, my x1. So x plus 0.25 minus x, and then boom, boom, I'm left with f of x plus 0.25, that's my y2, minus f of x, that's my y1, over 0.25. That's that h, that's that distance here. And so you can see here, now this is my line here. It's getting closer and closer and closer to the actual tangent line that I want. And now look at this, see, I'm even closer now. Let's say our h is going to be 0.1. That's going to be my change now. So then I have x plus 0.1 and then f of x plus 0.1 like that. So again, it's just x2, y2, same thing. So I'll put here x plus 0.1. That's what I added. So again, going to use that. So I'll do f of x plus 0.1 minus f of x all over. You've probably seen the pattern now. H is just my change in my x down here. So I'm just going to go ahead and write that down here, 0.1. So you see I'm getting closer and closer and closer to 0, which means now, see this line, this average rate of change? It's getting closer and closer and closer to the tangent line that I actually want. And as you've probably already noticed, okay, h is approaching 0, but it can't actually be 0 here in this situation because we'll get 0 on the bottom, which means it's undefined. But when we start using functions, you'll see why this will actually work when h approaches 0. Okay, so here's an example of actually using this approximation function with an actual function here. We're using f of x equals x squared. So let's plug in what we know. So I'm going to start right here, f of x. We're given f of x is x squared. So we put x squared there. So minus x squared. Now this is the part some people have trouble with right here. f of x plus h. What this means is, remember, put that into your function. F of x plus h. X plus h goes into your function. So this is my function x squared. I'm putting in x plus h for x. So it'll be this, parentheses, x plus h squared. See, I put in x plus h in here for x. So then over h. Now let's try to simplify this. So this first. What is x plus h squared? If you remember that from algebra 2, you're foiling it, we'll get x squared plus 2xh plus h squared minus x squared all over h. Now we can do some math, some good old math, good old baby math. So, okay, I have x squared minus x squared. So that goes boom, boom. All right. Now I'm left with 2xh plus h squared all over h. Look at this. This is good. This is good. Now we can start reducing things because we have h's and everything. So that goes away. Cross out. Cancel out an h from everything. We're left with 2x plus h. And so remember, h is approaching 0. So now that we have this, we can say, okay, we're getting so close to the point that we're actually at the point. So h is 0. So 2x. This is our answer. So what this represents is the slope anywhere on our curve x squared. So for example, if I'm here where x equals 2, to find the slope there, I'm using that equation. So here, to find the slope of this line at that point, I'll say, okay, 2x, that's my gradient or my slope function. So to find the slope here, I'll do 2 times 2, 4. I put in 2 here because my x was 2, remember? So now what if I'm here? Use the same slope equation. So to find the slope there, I'm going to put in 1 for x, 2 times 1. So then the slope is 2 here. So I can find any slope on this curve now with this function, 2x. That's what that means. This is my gradient function on the curve x squared.